Good morning, boys and girls. For science today, we are going to be hearing about reflection in mirrors. We've heard about that already a little bit from the Delta Reader. We heard about reflection being basically light bouncing off a very, very smooth surface and reflecting back to you. Now, that happens with a mirror most perfectly because the angles are just straight back because the surface is so smooth. But it can even happen with a smooth surface like a book or a plate or spoon. I would encourage you to try that at home, noticing, and we'll talk about spoons actually with the concave and convex lenses tomorrow. But some very smooth surfaces will show reflection, whereas like a tree or a rock would not show reflection because it's so bumpy that the light would reflect off in different directions and not right back to you. So let's hear about reflection in mirrors today. So most light that reaches your eye is reflected light. When light hits a surface, some of the light bounces off the surface. The light that bounces off the surface is referred to as reflected light. Most objects reflect some light. Now, why can you see your reflection in some surfaces like glass, but not in others such as a wall? Now, it's not about flatness because a wall is very flat, but we can't see our reflection on a wall. The answer lies in how light is reflected off of the surface. When the surface of an object is very smooth, such as the surface of glass, light rays from a source all hit the surface at the same angle. Now, in accordance with the law of reflection, all the light rays reflected by the object then bounce off the surface at the same angle. Now, you probably have played with bouncy balls before where you hit a ball against a wall, and depending on the angle where it hits, it's going to come back at that angle, right? So if it is a wide, like from above, bounce here, it's going to bounce back at the exact same angle. In math, you'll learn about angles a little bit this year, but mainly next year, like the degrees of the angles and all of that. So basically, if it's going to be kind of tight, then it'll come back as kind of this tight angle. And if it's a big angle to begin with, it comes back at a big angle. I encourage you to play around with that with a bouncy ball at home if you have one, or a basketball against the wall of your house if you've got something like that, or soccer ball. So the angle changes and, depending on the angle that you hit it or kick it at, it comes back at that same angle in an opposite way. So it's the same with reflection. So if our faces are being seen very, very, very clearly from a mirror, it's because the light is being reflected so straight that you can just see completely your face. Now, this type of reflection is known as regular reflection. When the surface of an object is not very smooth, though, such as the surface of a wall, light rays hit the surface at different angles. Because this is not super smooth, most walls are painted and have some texture. Or a brick wall would definitely be textured. You can feel the bumps. Now, in accordance with the law of reflection, all the light rays reflected by the object then bounce off the surface at different angles. This type of reflection is known as diffuse reflection. So it is still reflecting light, but it's not showing the actual reflection of the object because it's bumpy, so it goes all over the place. Now, mirrors exhibit regular reflection. Highly reflective mirrors have a very smooth glass surface that is coated with a silvery material. The silvery material reflects almost all light that hits it. So it's not just a smooth glass like window, but it's also got that coating on the glass so that it reflects almost all of the light. And the result is that you see an image of yourself. Mirrors can be what are called plane, like an airplane, but that's referring to like a flat surface, concave, or convex. We'll talk more about concave and convex lenses tomorrow, but a plane mirror is what you almost always see. So like in your bedroom or bathroom, you probably have a mirror that is just a flat mirror against a wall. Concave and convex mirrors show reflection, but they're curved. Concave caves in, just like an actual cave, think of that. And then convex curves out. So a mirror with a perfectly flat surface is known as a plane mirror. In a plane mirror, an almost exact image of the object is reflected. Use what I used yesterday to show an almost exact reflection. So images appear right side up and they are accurate in size. So in your bathroom above your sink, if you look, it looks like the same size looking back at you. And it also is right side up. It is your head right here, your feet going down. There are other mirrors that flip it, but a regular plane mirror shows basically the same size and everything as what you would normally see. Now, they are used in instruments like cameras, microscopes, and telescopes to reflect and change the direction of light as it passes through a lens so that you can see an image. Now, concave and convex mirrors are mirrors with curved surfaces. When the reflective surface of a mirror bows inward from the edges, it is a concave mirror. So once again, I think it's helpful to think of an actual cave where it actually comes in. But I will also show you an image of that now. Okay, so here's a concave mirror. That's the reflective surface part, this blue. And here's a convex mirror, which we'll get to in just a little bit. A convex mirror has the reflective surface coming out, and this hard surface is the part that curves in. Here is a concave mirror. Notice what's happening in that concave mirror. So, depending on where an object is located in relation to a concave mirror, the image formed may appear larger or smaller than the actual object and may appear right side up or inverted or upside down. If you look at your reflection in a concave mirror, you'll see that as you bring the mirror closer to and farther away from your face, the reflected image actually changes. The image of an object reflected in convex mirror, which we'll get to, also changes depending on where you're at. So here is, this person's hand much closer to the convex mirror, the hand appears larger. But if she were to back away, it would change the size of what the reflection is. Notice also that parts of it are inverse, they're upside down. This is going to use vocabulary that you don't necessarily need to know, but this shows you that light is being reflected off at different angles, and that's why it appears to be a different size, and sometimes it appears to be upside down. Notice kind of a weird shape to the car, and the space does not look real. Okay, now let's look at convex mirrors. A convex mirror curves out, remember. So a convex mirror, the closer an object is to this type of mirror, the closer and larger the reflected image appears. So if you're closer, then everything looks bigger. Concave and convex mirrors can be used to enlarge images and make them appear closer. This is true of, you can see like the interior of some buildings here, but also, yeah, like some big shipping trucks. Those would have possibly some convex mirrors to make things look closer and larger. And if you're closer to that convex mirror, the larger the image appears. Okay, so those are concave and convex mirrors. That is all for this little portion of the lesson. There are some notes to take as well, just like we've been doing lately, where you take notes immediately on some of the things that we just talked about. So I'll have you do that, and I'll see if there's a good little concave and convex video that would show you some excellent visuals of what we just talked about as well. Hope that you are having a wonderful day. Remember, this is a very short unit. We'll take a quiz or a test actually on Friday. So we just have one more lesson for light that we'll get to tomorrow. Have a great afternoon. I'll talk to you later. Bye.